we need to solve this system of equation using the inverse matrix method. Now, it's 3 equations in 3 unknowns, alright? Now what we're going to have to do is follow some steps. We need to, first of all, find the determinant. Oh, but by the way, first, before that, write in matrix form. Write in matrix form. So we have, writing in matrix form, we have a 3x here. This is 3, and a negative 4y, this is negative 4, and a 1z. Remember, the 1 is there, it's just that you don't write it. 1. And we have a 1x, 2y here, write the 2, 1z, we write the 1. And we have a 1x here, we write the 1. Negative 3y, we write the negative 3. 1z, we write the 1. We have a x, y, z here equals 6, negative 2, 3. So we have a 6, negative 2, 3 here. Alright? So we have 3x minus 4y plus z equals 6. 3x minus 4y plus z equals 6. Alright? X plus 2y plus z equal negative 2. Now it has the second equation, and the third equation, 1 times x, which is x, minus 3y, right? 1 by x, which is x, minus 3 times y, minus 3y, plus z equals 3. Alright. Now, we're going to find the determinant of the 3 by 3 matrix. We have a 3 by 3 matrix here. We find the determinant of it. Now, when you find the determinant, you can work across any row or down any column you want. I have a habit of just working across row 1. So let me just do that. First of all, before we talk about the determinant, let's look at a certain argument here. If you call this matrix A, alright, let's call this matrix M. Usually they say A, but let's call this matrix M. Multiply by this one, call it X. M multiplied by X equal, this is the answer, let's call it A. If these were numbers, you would say X is equal to A over M, right? You would divide both sides by M. But in matrices, we can't really just divide straightforward like that. What we have to do is this. Remember, if you have a number n and you have, say, a number m, and if you divide n by m, is like saying n times the inverse of m, right? So a number times 1 over a second number would be like the first number divided by the second number. You remember that? So now, what we do is multiply m by m inverse, multiply a by m inverse as well. So if we're going to find the inverse of the 3 by 3 matrix. In order to find the inverse, we find the determinant. Find the determinant of M, what we call M. This 3 by 3 matrix, we call it M. Right? You may see it in other videos, in notes and so on, it's referred to as A. Right? But anyway, we're going to find the inverse, the determinant. Now, the determinant of that matrix is, let me just expand across the first row. It's going to be 3 times the elements you see when you cover up the row and column with 3. And you have negative 4. But remember the place signs at the same time. You have this thing they call the place signs. You have plus, minus, plus, minus, plus, minus, plus, minus, plus. You start with a plus. And you will not have a plus beside another plus, or above or below it. Same thing with the minus. You won't see a minus beside another minus, or above or below another minus, right? So 3 times the elements you see when you cover up the row and column with 3. Let me see something here. Suppose I have what would I want now? I have this blue rectangle here. Okay, I'm going to use this for the covering up, and I have another one here. Alright, let us cover up the row and column with 3. What do you see uncovered? What you see uncovered are the 2, 1, negative 3, 1, right? So you're going to have 2, 1, negative 3, 1. And you assign a positive to the element that is in row 1, column 1, right? Now we move on to the element in row 1, column 2, that's negative 4. You cover it up and cover this up. So it's going to be, you assign a negative to the negative 4, and you multiply it by a certain determinant. The uncovered element would be 1, 1, 1, 1 here. Alright. So you have 1, 1, 1, 1. See that? And then here you have this 1 here, which will have a positive assigned to it. So it's plus 1 times this determinant. When you cover up the row and column with that 1, I just here 1, 2, 1, negative 3. So it's 1, 2, 1, negative 3. Alright. Now, what you're going to have is 3, go to 3 times 2 by 1, which is 2, minus 1 by negative 3, which is negative 3. This is going to be a plus 4, since a minus negative 4. 1 times 1, which is 1, minus 1 by 1, which is 1, plus 1 times, going to be a 1 by negative 3, which is negative 3 minus 2 by 1, which is 2. Okay. So there you have that. So it's 3 times 2 plus 3, because 2 minus negative 3. So it will be the same as 2 plus 3. which is 5 plus, this will be 4 by 0, plus 1 times negative 3 minus 2 will be negative 5. Alright, negative 3 there, negative 5. So this will be 15 minus 5, which is 10. Alright, so the determinant is equal to 10. So we know the determinant. The next thing is to write or find the matrix of cofactors. Alright? Now, that means we're going to cover up the row and column for each element. Assign their place signs and find the determinant, the 2 by 2 determinant of the uncovered elements, right? So you can see it's quite a bit of work you have to be doing when you solve 3 equations in 3 unknown using the inverse matrix method, right? So now, the matrix of cofactors, what could that be? Let me call it C. That matrix of cofactors would be, alright, let me do this first. It will be determinants, this determinant, this determinant, this determinant here, this one, this one, this one. Just setting up the frame from now. This one, this one, this one. Alright. And then we apply, assign the signs. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Alright. Now, the element in row 1, column 1. That's the 3 here. We cover it. And we see uncovered 2, 1, negative 3, 1. We did it before. Let's just look at it. So it's 2, 1, negative 3, 1. Then the other one, cover it, and we see 1 uncovered are 1, 1, 1, 1. So we find that there will be 1, 1, 1, 1. And then for the cofactor in row 1, column 3, we cover up the element in row 1, column 3. And we see uncovered 1, 2, 1, negative 3. So that's 1, 2, 1, negative 3. Alright. Oh, my, I wrote them in the wrong place. Should be up here. 1, 2, 1, negative 3, right? Then for the cofactor in row 2, column 1, we cover up the element in row 2, column 1. Uncovered are negative 4, 1, negative 3, 1. So that is negative 4, 1, negative 3, 1. Then this one, row 2, column 2, cover up the element, and we say uncovered are 3, 1, 1, 1. So we have 3, 1, 1, 1. Then in row 2, column 3, cover this, and we have 3, negative 4, 1, negative 3. So we have 3, negative 4, 1, negative 3 uncovered. So here now, we cover up the element in row 3, column 1. We have negative 4, 1, 2, 1. So that's negative 4, 1, 2, 1. Then row 3, column 2, uncovered are 3, 1, 1, 1. So we have 3, 1, 1, 1. And the last one, cover up the element in row 3, column 3, and uncovered are 3, negative 4, 1, 2. We have uncovered 3, negative 4, 1, 2. Alright. And this type of question should attract a lot of marks, You see the amount of work we have to be doing. So then, the matrix of cofactor equal. We have 2 by 1 minus 1 by negative 3. A positive 2 by 1 minus 1 by negative 3. So 2 by 1 is 2 minus 1 by negative 3 is negative 3. Alright. So we have that. And it's a positive, so we don't have to worry about it anymore. We have to adjust it. This one is a negative. There is negative 1 by 1 minus 1 by 1. Negative 1. 1 times 1 is 1, minus 1 by 1 is 1. Then the other is a positive. Let me just put the plus, minus, plus there. This will be 1 by minus 3, minus 2 by 1. So it's 1 by minus 3, which is minus 3, minus 2 by 1 is 2. Okay. Let me just put the curve or the bracket around the matrix from now. This one here is a negative, so I put the negative sign. It's going to be in the bracket. Let me just set them up from now. Positive, negative, positive, something in brackets. Minus, something in brackets. Positive, something in brackets. Minus, something in brackets. Plus, something in brackets. Alright. What's going to be in this bracket now? Negative 4 by 1 minus 1 by negative 3. So it's negative 4 by 1 is negative 4 minus 1 by negative 3, which is negative 3. This one is 3 by 1 minus 1 by 1. 3 by 1 is 3, minus 1 by 1 is 1. Then negative 3 by negative 3, that's negative 9 minus 4 by negative 1, so it's negative 9 minus negative 4. So negative 9 minus negative 4. Then we have negative 4 by 1, that's negative 4 minus 1 by 2 is 2, so it's negative 4 minus 2. Negative 4 minus 2, so negative 3 by 1, 3 minus 1 by 1, which is 1, 3 minus 1, so this one is 3 minus 1, 3 by 2, which is 6, minus negative 4 by 1, which is negative 4. Okay, we have run out of scrolling space, Let me just put an equal sign here. This is equal to, and then 2 plus 3 is 5, so we're going to have 5 0. This is going to be 0. I'm looking at that. See a 0. This one is what? Negative 5. So this is negative 5. And we have, this is negative 4 plus 3. Negative 4 plus 3 is negative 1. So minus negative 1 is a positive 1. So we have a positive 1 here. Now this is 3 minus 1. That's 2. Negative 9 minus negative 4. That's negative 9 plus 4 is what? Is negative 5. So negative 9 plus 4 is negative 5. But we have a negative 5. Because we have a negative outside here. So negative 5 is a positive 5. 5 here. And we have a negative 4 minus 2. That's going to be negative 6 here. And we have a negative 3 minus 1. 3 minus 1 is 2. And then a minus here. If you have negative 2. And then 6 minus negative 4. That's 6 plus 4 is 10. Okay, that is the matrix of cofactors. Right? Alright. The next step would be what? Let's draw a line down and work on the other side of this line, because we have run out of scrolling space. Can't scroll down anymore. Oh. Alright. So the next step is to transpose the matrix of cofactors. So we have CT equals. Now the thing is, when we transpose this or any other matrix, what we have to, before I do the transposition, let me copy this thing. Let me copy and put it over here to make life a bit easier for us. This is the matrix of cofactors. We're going to transpose it, right? Now, if we, let me see now, let me get a rule. No, this is not the ruler that I want. I want a ruler. We can turn the ruler. Alright, good. You see this? What we do? You see this row, we turn it into a column. So instead of 505 going across, 505 will go down. So we swing the rows, pivot it around the 5, swing it down. Now we have a 505 going down instead of across. So we're going to have a 505 down. So we swing, we have swung row 1, let's swing row 2 as well. Now you see row 2, it will be pivoted around 2, right? So if we have this 1, 2, 5 and we swing it this way and line it up, it will be a 1, 2, 5 going down in the middle. So this will be 1, 2, 5, and then here now you see the row 3 will pivot it around the 10. If we consider swinging this row up, pivoting around the 10, right? We swung this down. So basically, alright, let's look at it this way. Basically, the rows will turn to column. Row 1 become column 1. Row 1, 5, 0, negative 5 become, I didn't write the negative in front of this. 5, 0, negative 5. Row 2 becomes column 2. That's 1, 2, 5. 1, 1, 2, 5. Row 3 becomes column 3. Negative 6, negative 6, negative 2, 10 going across to column 3. Negative 6, negative 2, 10. Now automatically you see that column 1, 5, 1, negative 6 going down becomes row 1, 5, 1, negative 6 going across. 0. Let me line them up. Okay, oh, there are. I'm not able to do that. Column 2, 0, 2, negative 2 becomes row 2, 0, 2, negative 2. And column 1, 3 going down, negative 5, 5, 10 becomes row 3 going across, negative 5, 5, 10. So that's the transpose. Alright? Now, after transposing it, you multiply the determinant of M by the transpose of the matrix of cofactors, right? That will give you the inverse. A inverse is equal to, what was the determinant again? Determinant is 10. Oh, 1 over 10. Multiply 1 over the determinant. 1 over the determinant time the matrix of cofactors, which is 5, 1, negative 6, 5, 1, negative 6, 0, 2, negative 2, 0, 2, negative 2, negative 5, 5, 10, negative 5, 5, 10. Alright, that's the inverse. Now, what we're going to do to find x. X, well, the name of a matrix is really should be in uppercase, you know, instead of using lowercase x, uppercase x, because name of the matrix x is equal to the inverse A inverse times the answer. Call it A. Call it A nx. Why I say A inverse? It's M inverse, right? I had called it M. I'm accustomed to using A for the first matrix, but call it M times the answer. We call the answer A. Alright. We could, you know, just do the multiplication here. 5 over 10 is half. And 1 over 10. Remember, when you multiply a matrix by a number, you just multiply each element in the matrix by that number, right? Negative 6 over 10 is what? 26, 3, 20, 10, 5, alright? Then 0. 2 over 10 is 1/5. Negative 2 over 10 is negative 1/5. Negative 5 over 10 is negative half. 5 over 10 is half. 10 over 10 is 1. Alright, so let's consider this. So x is equal to the inverse which is half 110, negative 3/5. half, 1/10, negative 3/5, 0 1/5, negative 1/5, 0 1/5, negative 1/5, negative half, half 1, negative half, half 1, multiply by, so it's going to be x equal this, multiply by the answer here, 6 negative 2 3, 6 negative 2 3. Now what do we get for this thing now? Going to be half by 6 plus 1/10 by negative 2 plus negative 3 by 5. Alright, row by column. So half by 6 plus negative, so it's minus 1/10 by 2 minus 3/5 by 3. That would come up here. Down here is 0 by 6, which is 0, minus 2 by 1/5. Let me just put 2 over 5. Or continuing with the way we were doing it. 0 equals 0 by 6 plus 1/5 by negative 2 minus 1/5 by 3, okay, then negative half by 6 plus half by negative 2 plus 1 by 3, okay. So the x is equal to going to be half by 6, which is 3. Going to need more space here. Going to be 3 minus 2/10 is 1/5 minus 3 is 9/5. Okay, this is 0 minus 2/5. 0 minus 2/5 minus 3/5, and the third element will be, remember, you know, we're not writing a 3 by 3 matrix, so it's going to be a 3 by 1, but we're finding out what the numbers are. Negative half by 6, that's negative 3, minus half by 2 is 1, plus 3, and that's what now? 3 minus 1/5 minus 9/5. If we use fraction, 5 3 15 over 5, 15/5 minus 1/5 minus 9/5 would be what? 15 minus 1. That's going to be 14. 9, 10, 11, 12, 13, 14. 14 minus 9 is 5. So it's 5/5. So the top here is 1. It works out to 1. 1. Now negative 2/5 minus 3/5 is negative 1. Negative 5/5, which is negative 1. Negative 3 plus 3 is 0. It seems like these are the answers. Interesting. Let us test them. And by the way, let me write them down first. It is saying x equal 1, y equal negative 1, z equal negative 1. Because it's in the form x, y, z, you know. So these would correspond. So it's 1, negative 1, negative 1. Let us test and see if it really works out. 1, negative 1, negative 1. If we say 1, 3 ones 3, minus 4 by negative 1 plus negative 1, that's going to be, we're testing equation 1 first. Let's see if this works out to 6. 3, 4 by negative 1, that's plus 4 minus 1. 3 and 4, 7 minus 1 is 6. Okay, it works for equation 1. Remember, we're saying x equal 1, y equal negative 1, z equal negative 1. Let's see how this works out. X is 1 plus 2 by y, but this is 2 by negative 1, so it's minus 2 plus negative 1 minus 1. So 1 minus 1 is 0, minus 2. So the minus 2 is left there. So it works for equation 2. Let's work it out for equation 3. X is 1, so it's 1 minus 3 by y, which is negative 1, plus z, which is negative 1. So this will be 1 plus 3 minus 1. 1 minus 1 is 0 plus 3. So it does work. It does work. So you see, x is 1, y is negative 1, z is negative 1.